clear আছে?
Yes, sir.
Now here we have x square plus x greater equal to 0. At the same time, this quantity, if you consider, now this quantity is always positive. This quantity is always positive because x square plus x is positive plus 1. So quantity is always positive. So no need to solve the left hand side. Only if we solve x square plus x plus 1 lesser than equal to 1. Now what we have, x square plus x greater than 0, at the same time x square plus x lesser than equal to 0. Take 1 on the right hand side. So now if you analyze this inequality, so suppose if I say a greater than equal to 0, at the same time a less than equal to 0, so both will be satisfied if a equal to 0. So these two conditions satisfied when only equality happen. So take x common, it will be x plus 1 which is equal to 0. So now x equal to 0 and minus 1. Check the solution. When we solve the trigonometric equation or inverse equation, whatever the solution we will get, we verify the solution. Put in the place of x0, so it will be tan inverse of 0, and here sin inverse of 1. So answer is pi by 2 which satisfied. Now again put minus 1, so this part is 0. Here again you are getting plus 1, that is pi by 2. Both the solution satisfied the given condition. Is it okay?
Yes, sir.
Now try to solve this question. Question number 2, sigma tan inverse 1 by 2 r square, and this value is equal to p. R runs from 1 to 50. So then you have to calculate what is the tan p value. Tan p is what? Okay, now tan inverse 2 by r square. Tan inverse. So in this method we write each term as the sum of two terms. So here this term we consider as rth term, okay, now which is equal to tan inverse of 1 by 2 r square. So this tan inverse we are going to write as a sum of 2 tan. So how can we write? Now we can write as tan inverse 2 by 4 r square by multiplying both side numerator and denominator by 2. Now this will be equal to tan inverse of, in case of tan inverse formula, 1 is required in the denominator, 1 plus something, so it will be 1, suppose plus 4 r square, and minus 1, it is 2. So plus 1 minus 1 cancel out. It will be tan inverse 2 by 1 plus this 4 r square minus 1 square, we apply the formula 2r plus 1, 2r minus 1. Okay, now next we write the numerator. So our tr is equal to tan inverse 2. 2 we can write as 2r plus 1 minus of 2r minus 1 divided by 1 plus 2r plus 1 multiply with 2r minus 1. So this rth term we can write as tan inverse of x 2r plus 1 minus tan inverse of y, that means 2r minus 1. So this is the rth term. The range of r is 1 to 50. The range of r is 1 to 50. So we take t1, first term we can write as tan inverse 2 plus 1 3 minus tan inverse of 1. Then t2, it will be tan inverse of 2 plus 1 4 plus 1 5 minus tan inverse of 3. Next t3, it will be tan inverse of 3 into 2 6, 6 plus 1 7 minus tan inverse of 6 minus 1 5. In this way we have to write T50. So it will be tan inverse of, now if you put here 50, so 2 into 50 100, 101, minus 2 into 50 100 minus 1 99. So when we add, we will get this T1 T2, so R is equal to 1 to 50. On the right hand side you notice that these diagonal terms cancel out. So here some term present by which these also cancel out. So we have tan inverse of 101 minus tan inverse of 1. So this we can write tan inverse A minus B divided by 1 plus A into B, which is equal to tan inverse of 100 divided by 102. So it is 50 by 51. Okay na? And this is given as P. This value is given as P. So now this tan inverse 50 by 51 is given as P. Taking tan both side, to 50 by 51, which is equal to tan of P. So tan of P is 50 by 51. So this type of series problem we have to use the telescopic method. We try to write each term as the sum or the difference of two terms. This breakup is not easy, which is defined as 16 to the power sine inverse x plus 16 to the power cos inverse x is what? Minimum value you have to find. So now look at this number. It is 16 to the power something sine inverse x. Sine inverse x lying between minus pi by 2 to plus pi by 2. So whatever the power of 16 you will take, the number is always positive number. Whatever the power you will take, that this number is always positive. This is also positive number. So when you have the positive number, suppose a and b, and you are going to calculate the minimum maximum value, always apply the AMGM inequality. AMGM inequality. That means if a and b are two number, both are positive, so a plus b by 2 greater than equal to a into b whole power half. So it is your a and this number is b. Take their addition, 16 to the power sine inverse x plus 16 to the power cos inverse x, then divided by 2, which is equal to greater than equal to product of the number. So it is 16 to the power sine inverse x and then 16 to the power cos inverse x and then whole power half. So what we have, this 16 to the power sine inverse x plus 16 to the power cos inverse x. Take 2 on the right hand side. So 2 times of 16 to the power sine inverse x plus cos inverse x. So which is 16 to the power pi by 2 and then whole power 1 by 2. So now 16 to the power sine inverse x plus 16 to the power cos inverse x, which is greater than equal to 2 into, it is 2 to the power 4. So 2 to the power 4 into pi by 4 cancel out. So it is 2 to the power pi. Now this will be 2 to the power pi plus 1. Is it okay? So therefore minimum value is this one, 2 to the power pi plus 1.
Sir, when did you say that we will apply this one AMGM at what condition?
AMGM, in always remember when you have the positive number. When you have positive number, always for maximum minima recall the AMGM inequality when the numbers are positive. Okay, now in other method you can also do, but this is the most suitable method. Otherwise you can take 16 to the power this cos inverse x, you can write in a different way, pi by 2 minus sine inverse x, then 16 to the power sine inverse x you can consider as y, then you can again calculate. But most easy way is using the AMGM inequality. Is it okay?
Yes, sir.
Okay, better. Now going for the another questions. Question number 41. You have sine inverse of something, that is x square, then x power 4 by 3, x power 6 by 9, in this way up to infinity, plus cos inverse x power 4 minus x power 8 by 3, then plus x power 12 by 9, and then up to infinity, which is equal to pi by 2. Here given that 0 lesser than equal to mod x and less than root over of 3. Then the number of values of x for which this is happened. So find the number of values of x, for which this equation satisfied. Question is clear. Sine inverse of something, then we will get pi by 2. So here we apply the same concept. So x square minus x power 4 by 3 plus x power 6 by 9, and up to infinity this value should be equal to x power 4, x power 8 by 3, x power 12 by 9. In this way it will go on. So now here, if you suppose this is your first term, this is the second term, and if you calculate the common ratio, so it will be x power 4 by 3 then divided by x square. So it will be minus x square by 3. So if you multiply the first term by minus x square by 3, you will get the next term. If you multiply this minus x power 4 by 3 by minus x square by 3, you will get x to the power 6 by 9. So our common ratio is here in this case minus x square by 3, and here if you calculate x power 8 minus x power 8 by 3 divided by x power 4, so in this case common ratio will be x power 4 by 3, negative x power 4 by 3. So now here we apply the formula, first term divided by 1 minus of our r, x square by 3 negative, and here first term divided by 1 minus of common ratio, that is x power 4 by 3. Okay, now so erase this part, this is not required, we already calculated. So common ratio minus x square by 3 and minus x power 4 by 3, minus x power 4 by 3. Okay, so now this will become x square by 1 plus x square by 3, and here we have x power 4 by 1 plus x power 4 by 3. Okay, now so now next we have here now 3x square by 3 plus x square. Here we have 3x power 4 by 3 plus x power 4. So 3 cancel out. We take x square common, so it will be 1 by 3 plus x square, minus take this term on the left hand side, so it will be x square by 3 plus x power 4, which is equal to 0. So either first term is 0, so that means x square is 0, which will give x equal to 0, or this term is equal to the 0, that means 1 by 3 plus x square is equal to x square by 3 plus x power 4. So when we multiply, we get 3x square, then x power 4, which is equal to 3 plus x power 4. So these two cancel out, so we have 3x square equal to 3, that means x is equal to plus and minus 1. Okay, now plus and minus 1. Look at the conditions. So 0 is one solution and mod of x should be lesser than root 3. So our solution is correct, है ना? So 3 solutions we have. Is it clear?
Yes, sir.
Chalo, 3 solutions satisfied our condition.
So basically that's why the modulus was given, because minus 1 is also one of the solution.
Minus
So it
1 one
will
of the solution, and
also satisfy.
and the thing is, suppose here you are taking the common ratio r, which is equal to x square by 3 minus of x square by 3. So now common ratio, if you take the modulus of common ratio modulus, it will be x square by 3, x square by 3. Now here 0 lesser than equal to mod of x less than root 3. So if you do the square, it will be x square lesser than 3, that means x square by 3 lesser than 1. So this quantity is lesser than 1, otherwise this series is divergent. So here mod of r should be less than 1. So to obey this condition, they will give these restrictions, so that r should be always lesser than 1. Is it okay?
Yes, sir.
Now if you want to verify whether it is right or wrong, so this restriction only for the r. This condition minus 1 plus 1 and 0, you put 1 by 1, so here what we are getting all 0, here cos 0, so pi by 2 we have. Okay, now then you put here 1 and minus 1. What will happen to 1 and minus 1? Here the restriction is if you put minus 1 or plus 1 in this case. One minus 1 by 3 plus 1 by 9 in this way. So you are getting these
So here again we have to calculate the infinite GP.
Infinite GP, that means here minus 1 by 3. Minus 1 by 3, then after addition we will get again pi by 2. Yes, these will happen. Yes, so 3 solutions we have. Minus does not affect, na, because here all the powers are even, so negative also become the positive one.
Yes, sir.
Okay, so 3 solutions we have here. Okay, Now going for the next question. It is one of the easy questions you can easily solve. Question number 13. X, y and z, these three number belongs to -1 to +1, and sine inverse x plus sine inverse y and plus sine inverse z. This value is given as 3 pi by 2 with negative sign. Now we have to calculate what is our x square, y square, z square divided by 3. This value is what we have to find. Sine inverse y, sine inverse z, each will be minus pi by 2. So minus pi by 2 and minus pi
Sir,
by
same
2.
type of questions were also there in class 9, 10. Like we used to
Yes,
give in cos A plus cos B plus cos C equals to
yes, 3 I
3 or
think.
something. Yeah,
3
yeah,
or
3.
minus
Then
3.
we need to take 1, 1, 1.
1 1 1 we have to take, yes. So sine of minus pi by 2 minus 1. Similarly you have y is equal to minus 1, z is equal to minus 1. So put here minus 1 square plus of minus 1 square plus of minus 1 square by 3. So answer will be 3 by 3, which is 1. Okay. Now we are going to solve one interesting question. It is question number 50. The value of k is given as tan inverse half of tan 2a, half of tan 2a plus tan inverse cot a plus tan inverse cot cube a, tan inverse cot cube a. Okay, now it is cot a, cot of a. So now we have to calculate this value. What is the value of box of k? Box of k is what? Here one restriction given on the angle pi by 4 less than a and less than pi by 2. So a lies between 45 degree to 90 degree. Then what is the value of box of k? Inverse x. So tan inverse of x plus tan inverse of y, it will be tan inverse of x plus y divided by 1 minus xy. The formula is valid when x is positive, y is positive and the product of xy lesser than 1. Now this formula will be tan inverse x plus tan inverse y, which is equal to pi plus tan inverse of x plus y divided by 1 minus xy. This formula we will apply when we know that x positive, y positive, but product of xy greater than 1. So now how can we confirm that which one we will take? Because if you take the cot of a, so cot of a in this range 45 to 90 degree, we know that cot a lies between 0 to 1. So that means this angle is positive, x is positive, y is also positive. So if cot a lies between 0 to 1, so if you take the fourth power, so it is always lies between 0 to 1, that means lesser than 1. So we no need to add a pi. Is it okay?
Yes, sir.
Why this restriction is given? So that we will decide whether we will add pi or not. That is the main question here. Now tan inverse, when we take cot a common, so here we have 1 plus cot square a. In the denominator, if we apply the formula, it will be 1 plus cot square a into 1 minus cot square a. So this part cancel out. We have cot a by 1 minus cot square a. Okay now. So now tan inverse upper part cot a, then 1 minus cot square a. Change this cot to tan. So what we have, tan inverse 1 by tan a. Then here we have 1 by 1 minus tan square a. So this will be tan a, and then 1 tan cancel out, hai na? In the numerator we have tan a, and here we have tan square a minus 1. 1 tan cancel out. If you want to write these things in the standard form, 2 tan a, if you want to write, so we required 1 2 here, number 1. So we put 1 by half. Next thing, denominator we have to change. So it is minus half into 2 tan a divided by 1 minus tan square a, so that we can use the formula. It is minus sign. So tan inverse minus half, this will be tan 2a. Now negative I will take outside, it will be minus sign tan inverse 1 by 2 and tan 2a. Now in full expression, first term is tan inverse half of tan 2a. This is the first term. When we simplify the other two terms, we get tan inverse half of tan 2a. So these two cancel out, and this is the value of k. So k is 0, box of k we get box of 0, and box of 0 is again 0. So this will be our answer. Is it okay?
Yes, sir.
Now
So can you wait for 1 minute? Yes, sir. Done.
now coming to the next question, question number 33. They said you have one cubic equation x cube bx square plus cx plus 1 which is equal to 0. The coefficient b is lesser than c. If the equation has one real root alpha, so this equation has alpha as a root, one real root is a alpha, then the value of this expression we have to calculate 2 tan inverse cosec alpha plus tan inverse 2 sin alpha into sec square alpha. This expression we want to calculate. Okay now. So given cubic equation has one root alpha which is a real root, b lesser than c is given, then 2 tan inverse cosec alpha plus tan inverse 2 sin alpha sec square alpha we have to find out. So when you are going to add, then what is the restriction on x and y, that is very important. Is it clear? So now
Yes, sir.
look at here, it will be 2 tan inverse. Now this cosec you can write 1 by sin alpha, this part is no problem. Here you can write tan inverse of 2 sin alpha we can write tan inverse tan inverse of 2 sin alpha, and this cos sec square alpha will be cos square alpha, which we can write 1 by 1 minus sin square alpha. Up to this is okay.
Yes, sir.
Now suppose you have this formula 2 tan inverse x. So in terms of tan inverse we can write tan inverse of 2x divided by 1 minus x square. This formula we can write. So now if you look at this one, suppose this is given to you, so you can directly write 2 tan inverse x. You have to identify what is x here. Sin alpha is the x. So now in the next line we have 2 tan inverse 1 by angle sin alpha, and here we have what, 2 tan inverse sin alpha. Your angle is sin alpha. So from both we can take 2 outside. So 2 tan inverse of 1 by sin alpha, and here we have tan inverse of sin alpha. Is it okay now?
Yes, sir.
Now the addition part is coming here. How to add? We can do one thing. Suppose you know that if you want to change this cot inverse x, you can write as tan inverse 1 by x. If you know that x is positive, but if x is negative, so it will be pi plus tan inverse 1 by x. Okay, now this is the formula that we know. So here how can we confirm that what is our sin alpha, positive or negative? Look at this cubic equation. We don't apply here the concept of discriminant. Here we apply the intermediate formula, intermediate value theorem. So in intermediate value theorem, first of all we calculate this. Suppose we consider this is our fx. So now we are going to calculate what will happen at f of 0. So 0 is the standard value, because after 0 the number will be positive, before 0 it is negative number. So if I am taking f of 0, so what will happen, this expression will give you 1, because this part is 0, this part is 0, this part also 0, but 1 is there. So that means f of 0 gives you 1, which is a positive number. Now if I want to use this restriction, b is lesser than c, that means I want to say that b minus c is less than 0. This condition I want to use. So in the cubic equation only b and c are the coefficients, all are the variable. X cube is variable, here is x, here is x, here is 1. So if you want to write this expression is b minus c, what value of x you have to assign so that it will become b minus c? What value of x you want to put here so that it will become b minus c? Whatever the constant will come,
So
minus. So now we are going to calculate, in the place of x is minus 1. So answer is minus 1, then plus b, then minus c, then plus 1. So if you cancel out these two, b minus c is negative. So what we observe, that our polynomial, suppose it is a cubic equation, suppose
Sir.
just give like this. For example, for the time
Sir,
being, we
can
consider
you
in this
repeat
way.
that intermediate value theorem again? I couldn't get it.
Now intermediate value theorem I am going to explain. Just here I am calculating two values. At the 0 your value is positive, and at 1 it is negative. Hai. So your polynomial gives you the positive value 1 when it is 0. So when 0, then it is 1. When it is minus 1, then your polynomial become negative. Suppose value is here. Okay now. So now what we have, suppose our polynomial is moving like this. Okay now. So now at minus 1 we have this negative value. At 0 we have positive value. So if you have one negative value, one positive value, then what you can say, that your curve at one times cut the x-axis at some point.
Yes, sir.
Okay now, at 0 value is here 1, but when it is minus 1 value is here, Now since it is a polynomial, it is a continuous curve. So this curve intersect at x-axis at some point between -1 to 0. So between -1 to 0 your curve cut the x-axis. Now this idea is clear. At
Yes, sir.
-1 curve is negative, at 0 curve is positive. That means -1 to 0, when your polynomial travel at least one time it cuts the x-axis, and here the condition given that you have only one real root. So that means your curve cuts x-axis only one time and both others roots are imaginary roots. So what you can say that your alpha is the real number which lies between -1 to 0. That means it is confirmed that alpha is negative. So since alpha is the negative value and sine alpha should be negative because alpha is negative, so this will imply your input sine alpha will be negative. So this sine alpha is negative because your angle is negative angle. Okay, now 0 to -1. So sine alpha is negative. So since sine alpha is negative, so here when you changes from tan to cot, from tan to cot, if I use this formula, what I can write, it will be cot inverse of x minus pi, which is equal to tan inverse of 1 by x. So this tan inverse of 1 by x, these things I can write as cot inverse sine alpha minus pi. So this will be what, 2 times of, this will be cot inverse of angle sine alpha minus pi, I write here. Then you have here tan inverse of sine alpha. So now cot inverse of sine alpha plus tan inverse of sine alpha, this input is same. So cot inverse x plus tan inverse x is pi by 2. So pi by 2 minus pi. So you have minus pi by 2. So answer will be 2 times of minus pi by 2. That means minus pi. Now it is clear.
Yes, sir. Sir, without doing the derivative, can we find the maximum and minimum?
Yes, without doing the derivative also you can apply the sine inverse plus cos inverse x formula. So it will be cos inverse of x plus sine inverse of x, then you have whole square minus 2 times of sine inverse of x, and then you have cos inverse of x. So this value is pi by 2. So answer will be pi square by 4. Now here we convert into the one ratio, one inverse function. So cos I can write pi by 2 minus sine inverse of x. So this will be what, pi square by 4 minus 2 into sine inverse of x into pi by 2. So it will be 2 sine inverse of x into pi by 2, and next will be 2 sine inverse of x, then we have whole square. So now I have a one quadratic expression in sine inverse x, in sine inverse x. So first of all we make this polynomial which is in sine inverse x as monic polynomial, taking 2 outside. So it will become sine inverse of x whole square. So if you take 2 outside, so from here you can write 2 sine inverse x. This pi by 2 you can write as pi by 4. Now this pi square by 4 become pi square by 8. Okay, now up to this is okay. It will be pi square.
Sir, what did you take common?
2 common from each expression. I am taking 2 common from this product, 2 common, so it will become pi by 4. From here I am taking 2 common, it becomes pi square by 8. So that if you multiply by 2, all the expression will be in the same condition, all the terms, है ना? Up to this is any doubt?
No, sir.
So now we try to write this expression as a perfect square. So this is a square minus 2ab. So 2a, now our b is pi by 4. Next we have b square, that means pi by 4 whole square. Now again we subtract pi by 4 whole square, and last term is pi square by 8. So from here to here we have a perfect square. So 2 times of sine inverse x minus pi by 4 whole square, and the remaining term we have pi square by 8 positive and pi square by 16 negative. So take the LCM, 8 into 2 pi square minus pi square. So here we have pi square 16. So now this expression when become the minimum, when it becomes the minimum, because this is a quadratic part, this is look like if you consider it is suppose some other quantity t. If t belongs to real number, then t square should be greater than equal to 0. So minimum value we have when this part become 0. So x, if I take 1 by root 2, so sine inverse 1 by root 2 is pi by 4. So this square term will be minimum when it is 0. So now our small m we get, small m is 2 into pi square by 16, so that means pi square by 8. Now small m is clear, minimum value.
Yes, sir.
Okay, now coming to this is minus 1, then sine inverse of minus 1 is minus pi by 2. So we have this negative value here, minus pi by 2. Okay, now so this will be minus pi by 2, then we have minus pi by 4. So multiplying by 3, minus 3 pi by 4. So now taking the square, 9 pi square by 6.
So why are you taking minus pi by 2 here?
Minus pi by 2, minus pi by 2 I am taking because this x is negative na. When x I am taking minus 1 minimum value, so it is negative, minus pi by 2 will occur, and here you have the minus pi by 4. So suppose minus 3 minus 2, so this number will be the maximize, but if you take 3 minus 2, this number will be reduced, you get the lesser number because one is positive, other is negative. So to maximize this quantity, you have to take the maximum value of sine inverse x. So maximum value of sine inverse x is plus 1. Sine inverse x is plus pi by 2. So one is plus pi by 2, other is minus pi by 4. So answer will be pi by 4. But if you take the negative pi by 2 at x equal to minus 1, so it is minus 90 degree, it is minus 45 degree, so it will be minus 135 degree. Is it clear now? So negative, then you do the
Yes,
square,
sir.
it will be the positive. So that is the reason you have to choose x is equal to minus 1. So now here we have pi square by 16. So now answer is what? 2 into 9 pi square, then pi square. So you have 10 pi square by 16. So after cancellation we have 8. So now it will be 10 pi square by 16. So this is your capital M. So now we calculate capital M by small m is 10 pi square by 16. Oh sorry, 10 pi square by 8. 10 pi square by 8. 10 pi square by 8, and here you have pi square by 8. So answer is 10 only. Is it okay? Any doubt?
No, sir.